Ania from your favorite artist Electronist here, and I was talking about this project that I have with a good friend of mine from allaboutyourkids.com. This good friend, he is from United Kingdom, from UK. He's not American. All my American friends, they disappointed me. Yeah, I only have left only UK friends right now. Unfortunately, the Americans are not really cool with other people. They say they help, but they don't really try to do it all the time. At least, probably they get bored and they didn't. Yeah, I don't know what's happening, but they they are weird. Let's say they are weird. I know I am too insistent on my trajectory. I know exactly what I want, and I will get it one way or another. And the Americans, they don't really like this focused, direction that I have, at least. I don't. So. I was talking with my friend from United Kingdom, from UK, from England. He said this. I think this may be affecting the stepping of your motor. It is not getting the correct current to the coils at the right time. He was referring to this stepping mode that I already have. He suggested me, he actually showed me this real screenshot of his oscilloscope. But his oscilloscope is having 4 channels, which is absolutely imperative, is absolutely necessary, is absolutely extra mega super good to have 4 channels, especially for motors. Not only for motors, for a lot of stuff, and I know this detail. And the 4 channels oscilloscopes are extremely expensive because the extra 2 channels. The oscilloscopes that have only 2 channels or only 1 channel, they are very very cheap. But those with 4 channels, about double in price they are. So, so this is the stepping that I'm using right now. He is actually mentioning here that he actually used a 4017 exactly what I used, the chip, the IC, the integrated circuit that I use, 4017. And these are the step pulses from his chip that he is having. And I jumped directly myself as well. As you can see, I also have a 4017. He mirrored my impulse that I have here for the motor. That's the discussion about how to command, how to signal, how to send the right signals to this motor, to this stepper motor actually. And he, get my attention about this very important subject that I kind of neglected it because I was actually very very concentrated on other logic parts of the circuit, and this little detail I kind of neglect it. Here I have the same screenshots that he gave me. These are his images from his oscilloscope here. So 4017 step pulses, and he was referring to 17LS164 that I don't have this chip actually, but he used it to show me how it should be, the real step of the motor, the signal step to the motor, how it should be like that in this form. And I understood perfectly what he told me. And let's see, where are you? Yeah, is this guy here, this other picture here. And he actually mentioned here that is for bipolar stepper, motors. So he told me, think about it, food for thought, think about it, because it is important. And I get the idea, I really get the idea. And the first step that I did, I jumped into my, I don't have this kind of funky oscilloscope. I have my Hercules, #1, but nah, it's not, I cannot compare it with what he is having there. But what I did, I jumped into my Proteus simulator here, and I put an oscilloscope on these 4 wires, signal wires that I have here. And these are commanding actually the L298. Make abstraction of this guy here because this is for testings right now. It's a current control chip, and I don't have right now good results with it. I will make a movie if I will get good results with it. But until then, let's say these wires are actually going directly to this L298 or whatever chip is there that is actually commanding the stepper motor. Okay, so let's see what this simulator is seeing, and you will be amazed. I am very amazed. So let's see. Let's play it. And it is automatic right now. And going to debug digital oscilloscope here, and let's pause it a little bit. And let's center it. And as you can see, all these pulses, let's go maybe like this, you see? And as you can see, is exactly like he is having here. 1, 2, 3. So it's starting and stopping. It's starting and stopping. It's exactly what I have here. Only the colors are a bit, inverse. But the pulses themselves are exactly like I have here, and that's very good. That's very very good. Okay, so so let's stop the simulation here. Also, you can see it running as well. It is running here. The motor is spinning, but this discussion was about my complaint about a special motor that I have, a small NEMA 8. Let me see if I can find it very quickly. Motors. NEMA 8. This is the guy. This is the guy that I have, and these are the specifications from when I bought it. And I'm complaining about it because it is extremely weak, and yeah, I really don't like it because it's extremely weak. It can merely turn a paper that I glue it to its rotor here, and it's very very weak. And I was thinking that I got a bad deal with it. But my friend here, he told me, well, check the pulses of the motor. Maybe, and I was actually thinking on this problem for some time long ago. I was, contemplating. Maybe I was thinking like that. Maybe the pulses that I have right now are not really specific for this type of motor that I have here. Maybe that's a problem. And my friend here, uh, he throwed me this bone. So what I did, I took this problem seriously. And what I did, I made this contraption here. This capacitor is not needed actually here. I was looking, this is the output of this discrete logic gate that I have here. This is a discrete logic gate, which is working actually. Let me switch to manual because right now it's automatic and you cannot see shit. And let's play it a little bit. So what it's doing, initially in the first place, I was thinking, I really thought on an OR gate, not on a XOR gate that I written here, because I figured it out. It's actually a XOR gate, which is an inverse OR gate. But I was thinking on an OR gate. So this part here, like this is the OR gate, I believe. Without the transistor and without this resistor, I don't know. I don't have it now. I don't have the other version that I had before. It was way more simple than this. And I was getting the signal somewhere from here, from this line. I was getting the signal, but the signal was very, very weak, like 1 volt or something. And I had to push up the voltage to 5 volts. And as you can see here as well, the entire circuit actually is running at 5 volts. And in reality, is eating like 100 milliamps. The entire circuit that you are seeing here. Without, of course, without this part, because this is the new part that I just thought about it. So I was thinking to upgrade it to be a very decisive high 5 volts and very decisive low 0 volts output. And this capacitor was for that arrangement without this transistor. I was getting a spike. And actually, I can show you. Here is his oscillogram that he got it from his real oscilloscope. And here was my result that I have when I have this spike. But I get the same result as his. And I was very happy with the result. But that spike was because I was not using a buffer, kind of buffering up the voltage. It was very low voltage. But after I've added this transistor with 1K pull up here, it started to be a decisive 5 volts and a decisive 0 volts. I was getting the right signal, the good signal, a very good signal on this input lines for this chip for L298. If you want to see the overview, how it's looking, I copied this entire circuit. I copied here, and then I did my business there, making the next circuit. And then I thought, well, let's see if first of all I have a chip in my arsenal of integrated circuits that I have. And my arsenal of integrated circuits is not that big. I don't have that many. I have 10 of each usually, but not that many models or there are a ton of chips in this world, and I cannot have them all. I have some, but not all. So I was curious if I'm having an OR gate, and I have 10 of them actually. And is this one 7432? It says here, and this is actually my OR gate chip that I'm having. So 7432, I have 4 OR gates in one chip. So that's very, very convenient because I can use them all 4. So basically one chip that is having 4 OR gates in it, and only one chip to do this conversion to what I actually need, to this second signal that I have. Stop. 100, 200 probably. Okay. Yeah, it's a little bit like a dick there, but it's like a little dick, but it's good enough. It's good enough. So we'll have to add this smoothing capacitor here to smooth out the signal. And this is the negative rail actually that I'm linking the capacitor. This is how it looks. Where are you? This is how it looks. I guess. So if I'm zooming in into the signal here, we can clearly see there is a tiny, insignificantly small blip there, like a little dick. But it's not really, this is actually commanding the motor itself, and that will not really interfere with anything. It's good enough. It's more than good enough, and we can actually make it more straight. That little dick that is having there, not having it at all actually. But for the moment, let me talk about something else also important. Let me switch to manual. So let's play it. So right now is when I'm commanding it from here, it will move. So actually, let me stop it and start it again. And when it's starting, we can see this is actually an OR gate because it's getting a signal, a positive signal on this diode, and on this diode as well here, exactly like here. Like this OR gates that I'm having here, its output is exactly like I'm having here. But on this original circuit that I made, without even realizing, because I was concentrated on making the thing powered to 5 volts and the signal to push it to 5 volts and to 0 volts, of course. And I didn't actually think it will not be an OR gate. I was very sure it will be an OR gate, but this is actually the inverse of this, and it must be an XOR gate, which is the inverse of the OR gate. So now when we are switching, you see these are two top lit, but the top LEDs are not lit, and vice versa here, and is exactly inverse of that. This doesn't matter at all. Absolutely, it doesn't matter. The motor will be commanded. It will get the signal correctly, and it will run. Let's actually see the motor how it's running. Right now, all the connections are made from this part. I didn't link these guys. I didn't link them to that input there. So everything is running from that chip, if you want. And also this guy is running as well. I know it's hard to, you see, you can see them both moving in the same time. And yeah, problem solved actually, problem solved. And it was a big problem. And I solved it with only one chip, with this OR gate chip 7432. And it's good to have a couple of different models of chips, logic chips or whatever, you know. It's good to have them and use them when you are desperately in need of them. So this is how I reached to this conclusion, to this circuit. By I wanted to show you this by using this strategy, if you want, by using this simple discrete components, you know, using this discrete components and then using the actual chip there here. It is a way of doing it, I suppose. Probably my way of doing it is a bit more harder, but it was intuitive. It was very, very intuitive to do it like this first, and then I thought maybe I can integrate a chip that it can do it for me, and I did. Actually, I also had to search if I'm having it into my arsenal, because that's a problem. That's a very big problem. If I don't have a specific chip, I cannot do anything. So that's why I jumped directly and very quickly to this discrete components gates, logic gates, if you want, and it worked absolutely fine. And the only thing is that the signal is inverse, but really it doesn't matter for the motor on the outside of the motor. So problem solved, pretty much problem solved. Next, I will have to make it on the board itself. And we will see how it will actually run this specific stepper motor that I have. Very problematic. I call him a bastard motor, stepper motor, because it's so weak. Let's see if this will solve the problem. I really hope it will solve the problem. If not, then it's really a special motor that it needs a special way of driving. Let me actually look. So this is my favorite website from where I can get the real information and not bullshit information. It's called Wikipedia, of course. And from Wikipedia, I'm on the page of stepper motor. Let's go here on the graphic, and this is exactly what I just did here. It's called wave driving. I don't know actually all the ways you can drive a motor. I know there are more than one way of driving a stepper motor, but I don't really play a lot to actually, you know, I'm not a specialist in stepper motors, but I know something, you know, like everyone else probably. So this was the 4017 signal that I was sending to the motor, and it was working like this, but probably not strong enough, most probably. This is the full step drive is called here, and let me actually make it more clear for anybody. So it's this part here. This full step is what I just did right now with that one chip, that one OR gate. I've actually, what I did, let me make it bigger. I ORed this signal that I had before, and I ORed it. I used the OR gate, and I realized this second stepping signal for the stepping motor. Now half step drive, if I can do it, if I can make this signal as well, then I am the boss. I am very good if I can do it like this. I'm not completely sure I understand it perfectly, but I do understand something. So we will see in the future if I can actually make a step drive or a half step drive of the motor. And this micro stepping, nah, I don't know. But yeah, it's sure. I can see some capacitors there. I can see some capacitors that I can add. Actually, yeah, it's the full step drive. I can transform it into a micro stepping. Yeah, actually, the second one is the one that I can add some delays here. Interesting. But I will not concentrate on micro stepping. I will concentrate for now only onto the full step drive that my friend suggested to me. Finish it, and if this will not work good enough, I will have to get down to the ground and make this half step mode as well. Probably. I hope not, but we will see. So for now, I have these two modes that are working absolutely fine in simulation. At least here in simulation are working absolutely cool, very good. I'm very, very upset that I don't have an oscilloscope in reality with 4 probes. I only have an oscilloscope that is having only one single probe, and it's shitty as hell. But I did my job. I did a lot of stuff with it, and yeah, I learned about oscilloscopes using it, and it was good. It was good so far. So I learned how to use it and how to, you know, and when to use it. But we will see in the future. So for now, this is absolutely good enough what I have here, and I'm very pleased with this one single chip that I can use to convert that original signal into this. And another problem that I will have to deal with, especially on the board itself, when I will build it, are these four transmission data lines that I have here. I will have to switch from this four into this four somehow. I'm not sure how, but we will see in reality. I hope you like it, and yeah, leave a like and thank you very much. All right, okay, bye bye from Romania.
Uh,